Welcome to the second video in the ProSave tutorial series. In this video, we will discuss scene prep with ProSaver and detail further the initialization function, late initialization function, and the complete scene prep function. We will also go over how to use the Pro mono behavior and how to load game data when scenes start. We are going to create a rudimentary character data panel for demonstration. Add a UI panel to the scene by going to GameObject, UI, Panel. Set the panel's alpha to 1 and change its name to UI Panel. Next, add an image. Change its object name to Name Panel. Set its width to 400 and its height to 50. Move it to the top left corner. Add a horizontal layout group to it and delete the image component. Add a text TMP child to the image. And make sure its width is 200 and its height is 50. Set the vertex color to black and the text to name. Adjust the alignment so the text is centered. Next, add an input field as a child to the layout group. Set its width to 200 and its height to 50. Set the font size of the placeholder and text to 25 and adjust the alignment. This is what we will use to alter the character's name. Add another image, change its object's name to Character Stats panel, and set its width to 400 and its height to 400. Move it to the left side of the UI panel. Add a vertical layout group to it and delete the image component. Set the child alignment to upper center and the spacing to 5. Create another image as a child of the Character Stats panel. Set that image's width to 400 and its height to 50, and rename the panel Stat Panel. Add a horizontal layout group to it and delete the image component. Now add 2 TMP text game objects as children to it and 2 button game objects as children to it. Set the width of the first TMP text object to 150 and make sure the height is 50. Change its text to Stat and its font color to black and its font size to 27. Adjust the alignment so the text is centered. Rename this TMP text object to StatName. Select the second TMP text object and set its width to 50 and its height to 50. Change the font size to 25 and the font color to black and the text to 0. Set it bold. Adjust the alignment so the text is centered. Rename the text object StatNumber. Now select both of the buttons and set their widths to 100 and the heights to 50. Rename the first button object IncreaseStatButton and the second DecreaseStatButton. Select the child text object of the IncreaseStatButton and set the text to plus sign and make it bold. Set the child text object of the DecreaseStatButton and set the text to minus sign and make it bold. Create text TMP under the UI panel and set its width to 400 and its height to 400. Change its text to abilities. Set its font size to 36 and its font color to black. Move it toward the top right of the UI panel and rename the game object Abilities List. Finally, create 2 buttons under the UI panel, set their width to 200 and a height to 50, and position them next to each other and beneath the abilities list. Change the text of the first button's child text TMP to Learnability, and change the name of the button's game object to Learnability Button. Change the text of the second button's child text TMP to Unlearnability, and change the name of the button's game object to Unlearnability Button. Save the game scene. We've created a rough character stat menu. You can imagine something, at least functionally, similar existing in a fully created game. Let's now create the manager scripts to control these various panels and allow for the updating and changing of game data. Create a script called Character Stats Panel Manager, and another called Stat Panel Manager, and another called Abilities List Manager, another called Name Panel Manager, and open the Character Stats Panel Manager. In default Unity, initialize consists of the methods awake, onEnable, and start. As explained previously, using any of these default functions to load your game data is problematic because of their unwieldiness and because they can cause throttling at the start of your game scene. To remedy these problems, ProSaver adds the initialize, late initialize, and complete scene prep functions. The easiest way to implement the initialize, late initialize, and complete scene prep methods in your game's monobehaviors is to simply turn them into pro-monobehaviors. Add the Using Pro Tools saver at the top of the Character Stats panel manager script and set the class to inherit from pro-monobehavior instead of monobehavior. Because pro-monobehavior inherits from monobehavior, they include all of the old monobehavior functionality, but expand on them to make managing scene initialization, especially when loading data, easier. Delete the start and update functions from the script. We won't be using the awake function either, but if you do ever need to use the awake method in a pro-mono behavior in a project, make sure to include base.awake in the awake method. Now add public override void initialize to the class and delete base initialize. Attach the character stats panel manager script to character stats panel. We are going to have the character stats panel manager spawn a stat panel for each stat in character data's character stats dictionary. To do this, we need to add a prefab of stat panel objects to a resources folder. Create a new folder in assets and call it resources. Make sure you spell it correctly, the spelling matters. Next, drag the stat panel game object from the scene into it. Now delete the stat panel object still in the scene. Now, return to the character stats panel manager script and add using protools.extension at the top of the script just under protools.saver. Pro Tools extensions are a series of extension scripts we give as a bonus with the ProSaver. They can help improve code readability and grant some minor extended functionality to many Unity built-in types. Check the website address included in the README for more details on the various extension methods. In the initialize method, add the following code. Character stats array stats equals character data dot return all stats. Skip a line. For each character stats s in stats, now within the for each loop, game object inst equals instantiate resources.load stat panel as game object. Next line, inst dot set parent game object. This code will spawn a stat panel object for each stat included in our game data and set it as a child of character stats panel. Note that because character data is set as a singleton, we can reference it directly with character data.data. But we have a problem. We need to make sure that character stats panel manager.initialize is called after character data.initialize. Otherwise, character data.data.return all stats will return an empty array. But that is one of the big advantages of using ProSave's initialize system. Unlike with the awake, onEnable, and start functions, you have control over the order specific pro-mono behaviors and other implementers of the iInitializable or iLateInitializable interfaces called their respective initialize and late initialize functions. The order in which classes call their initialize function is determined by their initialization weight. The lower the weight, the earlier the particular pro-mono behavior will be called in the initialization process. This is also, predictably, the same for late initialize, except that late initialize is determined by the late initialization weight. While not strictly necessary, we strongly advise that you set all of your initialization weights with negative numbers and all of your late initialization weights with positive numbers. This makes it easy to tell them apart at a glance in the editor. You can set these weights in script in the awake or start functions, or you can set them in the editor. Select the game data object in the hierarchy and set the initialization weight field of character data to -2. Great! Now we can be certain that character data.initialize will be called before character stats panel manager.initialize every time. Initialize is generally called before game data is loaded from the driver server. This makes it the best place to set up the default state of the scene. On the next script, we are going to work on late initialize, which is called after data is loaded from the drive or server. Open the name panel manager. Add the using protools.saver at the top and set the class to inherit from pro-monobehavior instead of monobehavior. Now add public override void late initialize and delete base.lateInitialize. Now add using tmpro to the top of the script and add a public field tmp input field and name the field input field. Next, add a public function named changeName that returns void and takes no parameters. Now, add the name panel manager script to the name panel. Apply the name panel child input field to the TMP input field. In the changeName method, add the following code. Character data name equals input field text. Next line, ProSaver save game. The first line of code updates the character name in the character data to match what is in the field. The second line tells ProSaver to save the game when the method is called. We want to do that here because we are changing data we want to save. Obviously, it is up to you when you want to save your game, but often it is best to save right after any data you are interested in saving is altered in any way. In late initialize, add the code input field .text equals character data.character name. This line will update the text input field to make sure it matches the data saved in character data after the data is loaded from the drive. Select Name Panel's input field child object in the hierarchy, then scroll down to the inspector until you find onValueChange and press the plus. Drag Name Panel over to the slot, then set the dropdown to NamePanelManager.ChangeName. This will change the name and save the game data whenever something is typed into the input slot. Now open StatPanelManager script. Add the using ProTools.Saver at the top and set the class to inherit from ProMonoBehavior instead of MonoBehavior. Add the code public override void late initialize and delete base late initialize. Add two other public methods that return void and take no parameter called increaseStat and decreaseStat. Add using tmpro under using ProTools.Saver. Add two public TMP text fields, one named statName, the other named statValue. Finally, add a public character stat field named myStat. In the increaseStat method, add the code character data.increaseStat myStat. Next line, statValue.text equals character data.return stat value mystat.toString. Next line, ProSaver.save game. In the decreaseStat method, add the code character data.decreaseStat myStat. Next line, statValue.text equals character data.return stat value mystat.toString. Next line, ProSaver.save game. Now, in the late initialize function, add the following code. StatName.text equals mystat.toString. Next line, StatValue.text equals character data.return stat value mystat.toString. Now, after loading data, Stat Panel Manager will update its text to show the value of the stat it is indicating. Now, return to Character Stat Panel Manager script. Under the line inst.setParent game object, add the following code. inst.getComponent StatPanelManager.myStat equals S. This will update the Stat Panel Manager's stat script to reflect the assigned stat. Now, go into the Resource folder and double-click Stat Panel. In the inspector, click Add Component and add the Stat Panel Manager script. Drag the stat name text over to the stat name slot and the stat number over to the stat number text slot. Click on the Increase Stat button. Click on the plus under OnClick, drag Stat Panel over to it, and select Stat Panel Manager, Increase Stat in the dropdown. Click on the Decrease Stat Panel button. Click on the plus under OnClick, drag Stat Panel over to it, and select Stat Panel Manager, Decrease Stat in the dropdown. Open the Abilities List Manager script. Add the Using ProTools.Saver at the top and set the class to inherit from ProMonoBehavior instead of MonoBehavior. Now add the public override void late initialize and delete base late initialize. Add two other public methods that return void and take no parameters called learnability and unlearnability. add using TM Pro under using ProTools.saver, add one public TMP text field named abilities list. Finally, add a private method that returns a string and takes no parameters called compileAbilityString, and add using system.text under TMP Pro. In compileAbilityString, add the following code. String builder. String builder equals new string builder. Next line, string builder dot append abilities colon. Skip a line. Ability array abilities equals character data dot return abilities. Next line, for each ability A in abilities, inside curly bracket, string builder dot append space. Next line, string builder dot append a dot toString. Next line, string builder dot append comma space. Outside of the for each loop, return string builder dot toString. This code will compile a string that lists out all of the character's abilities. In late initialize, add the code abilitieslist.text equals compileAbilityString. In the learnAbility method, add the code character data.data.learnRandomAbility. Next line, abilitieslist.text equals compileAbilityString. Next line, ProSaver.SaveGame. Add using system.link under system.text. In unlearnAbility, add the code ability array abilities equals character data.data.return abilities. Next line, if abilities.length is greater than 0 within the if statement. Character data.data.unlearnAbility abilities.last. Next line, abilitieslist.text equals compileAbilityString. Next line, ProSaver.SaveGame. Back in the scene, select Abilities List object from the hierarchy and attach the Ability List Manager to it. Drag the Ability List object over to the Ability List slot in the Abilities List Manager script. Select the Learn Ability button from the hierarchy, click the plus under OnClick, drag Abilities List over to it, select Abilities List Manager from the dropdown, and then Learn Ability. Select the Unlearn Ability button from the hierarchy, click the plus under OnClick, drag Abilities List over to it, select Abilities List Manager from the dropdown, and then Unlearn Ability. We have now successfully coded all of the menu items for our menu. They will update after data is loaded, and will save the game after values change. You may have noticed that several call the late initialize method to update data after data has been loaded from the drive. That is common in games. To prevent throttling, the number of classes that have their initialize or late initialize called in a single frame is determined by the initialization threshold and late initialization threshold, respectively. You can change these numbers by adding the code prosaver.initializationThreshold equals whatever threshold you want for initialize, and prosaver.lateInitializationThreshold equals whatever you want for late initialize. The default number for both is 10. If the number of pro-monobehaviors in your scene that are set to call these methods are greater than the threshold, after the threshold is met in a single frame, the process will delay into the next frame. This will prevent the CPU and GPU of the computer from becoming overburdened. For best results, you may have to test different threshold numbers for your particular game and the particular platforms you are targeting. Larger thresholds potentially allow for shorter loading times, but are more likely to throttle, whereas shorter thresholds will do the opposite. In this video, we set up a rudimentary stat menu and learned how to control the order of operation of initialize and late initialize functions by changing the initialization weights. This scene is now almost ready for testing, but still lacks any script calling for the game to load data when the scene starts. In the next video, we will add a script to do just that. We will also test the scene and learn how to add loading screens to our games. We will continue with the tutorial in the next video.